Run like the wind, bullseye. Alright. Actually, hold on 1 second. If you remember, we got a mock exam on Saturday. I finished my Shelton State ACT thing on Saturday, 10:30. And so I could do food at 12, start at 12:30, or I could even get the food and be up here at 11:30. And then we could start around 12 to get us out of here a little bit sooner. What do y'all want to do with that?
Can I use the bathroom?
Can I use the bathroom too?
How long does it take?
About 3 hours.
I thought this was to wait.
Oh yeah, dude. Yeah, well, hey guys, we gotta decide first before we go to the bathroom. Sprig.
What are we doing?
A what? I'm not doing a field trip to the bathroom. Like, we're adults-ish. Okay.
Here's like 15.
Guys,
15.
what do we, food at 12 or food at 11:30?
11:30.
11:30, 12. You just want it to be a little bit later?
No,
or
I mean,
you
I'm
need-
saying something like that.
I'm so scared.
Okay. Can you make it 11:30 or do you need to be 12?
I can, I just don't want it.
Preferably 12 because I'm gonna have to
That means you just have to leave the house by 10:50. Alright, so, hey guys, we gotta get going with Bivariate data today. What?
She said it was that's not yours.
Take the what? That's fine. Whatever you choose. The 21st is the makeup AP stats exam. Alright, so, food, I'll have it here at 11:30, it'll be pizza, I gotta figure out which pizza place we're going to.
Right away.
Which store are we going to?
I agree with
The one right here. Hey guys, I'll figure that out, I need us to focus here.
Yes.
We're gonna finish correlation today, be aware, tomorrow I think is when we get to the horsepower lab, so you need to bring shoes you can run in.
What? I can run in Crocs.
Please bring real shoes. Listen, y'all got 30, 45 seconds to go use the restroom because I am starting. By me, I mean Miss Kowalski is starting.
Are we doing that here or?
You don't need your phone to go to the bathroom. What the frick is wrong with people?
Hold on, I gotta go pee too.
Jaden?
Holy cow.
Run.
Like, we don't ever have to do it in the middle of class. Why we gotta magically do it today?
Can we just start?
Right.
Can we
What is
start?
Yeah, we're starting without them.
Okay.
Wait,
Miss Kitty.
Yeah.
Can I move this camera back? I'm scared it's gonna fall.
Why would it fall?
I don't know. Grab me.
It should be fine.
You sure this guy's a professor?
I'm gonna smack it.
No, but he was the
Wasn't
one
he
who gave us the
Proctor?
test. Yeah. He's genius.
Who?
You know?
Kate Bowen.
Oh, I have him.
Is he good?
Yeah.
Yes.
Like how good?
He's who I would take if you're taking a math class.
Yeah.
Sorry.
Oh yeah.
Just not BC Cal because I'll fight you.
Well, okay, I was looking at taking discrete math.
Wait.
I like discrete.
No, I did well in discrete.
Yeah, discrete's fun.
Different Q.
Over the summer,
Different.
it was either that or like an engineering class. And I know which one to take. 'Cause
Do
everybody else said
engineering in the
engineering.
summer, it's gonna be a lot easier than when you take it in a regular,
Well, it's like engineering foundations. It's like a not actual
already
engineering.
easy.
Yeah, it's just like you.
Hey, let's go with correlation stuff.
Anyway,
Yep.
oh, we talked about this already.
Yeah.
Yeah.
So let's just do as a quick review. What is correlation and measuring? Yeah.
Correlation.
Low,
Strength and
low, two variables.
Strength.
So strength,
Strength of
the association between two variables,
form.
the form, whether it is
Positive. Negative.
that's direction,
Linear.
linear or
X quadratic.
It's either linear or.
Non-linear.
And then what was the other one?
Non-linear.
Was that other,
That was
the
direction.
direction?
positive or negative.
Mm-hmm.
Yeah.
Crazy or
Hey.
Yeah.
Relationship, could you say that?
Inverse relationships are
Because that's
show
what I see
a
stats.
rational function.
What about net relation?
Yes,
Yeah.
essentially. Okay, so we did all this.
Yeah. This has makes me pissed.
Get some more practice with all that. Did I not put in the notes page? I guess I accidentally took out that slide.
Teach us, Miss Kowalski.
I'm so scared.
Oh, that's just later. Oh, was this oh, this is the next set of questions that we didn't get to. That's why it's this. I thought that was check your understanding. Okay. Take it away.
Alright, we're on the 3.2 correlation, mathematic activity, get it out. Alright, here's the data. We're using the Barbie bungee that we didn't actually do. Just communicates us. After class, the group measured the distance. This is number 4. It's on the back of that page.
Is it 3.2?
Yep, 3.2. Alright, after class, the group measured the distance traveled for 12 rubber bands. How will adding this point to the scatter plot affect the correlation R? So the number of rubber bands will be 12. Oh, it's this one up here. This is what they added. So they added this point.
Oh, no.
How will this point affect the correlation R? What do we think?
Meh,
Not really.
I think it's the same. It's a back over.
because it's on the thing.
The line of best fit. Yeah, it's pretty. Yeah.
It looks pretty in line still. All right. I don't know exactly what they said on there.
It would strengthen it. So if you have, because look, there's a couple data points down here that are not quite on that line of best fit, but if I take one point that's going to be really close to that line of best fit, that's going to increase my correlation. Data points that are close to your line of best fit, it'll strengthen the correlation. So it'll increase it.
Increase. All right, and then the group accidentally typed 85 centimeters for 5 rubber bands. That'll be right there. How will this point affect the correlation R?
Weaken it.
Weaken it. Why?
It's off the line.
It's off the line. It's not close to the line.
It's not gonna.
I ain't nothing like y'all.
Beautiful.
One thing I will say with the strengthen versus weaken, be careful, because when we say it weakens it, if it was a negative slope, right? Let's say R was originally negative 0.85. How would that second data point change affect the R value? Would it make it more negative or make it closer to 0?
Closer to 0.
Why closer to 0?
Because it would weaken it. And 0 is like no correlation.
So remember, 0 is no correlation. A perfect positive 1 means the data is perfectly what?
In line.
So perfectly linear, but it has a positive slope. What does a negative 1 indicate?
Perfectly linear.
Still linear, but it has a negative slope. So when we say weaken, make sure you understand that makes the correlation closer to 0. Strengthening it makes the correlation closer to 1 or
So can the
negative
like
1.
line of best fit only be like negative 1 and the opposite 1? Like, is that the most like? Oh,
That is the highest value. Yeah, a positive 1 or a negative 1 is a perfect line.
So the
Perfect
most
set of
extreme.
linear data.
That's the most extreme.
Alright. Alright, template for interpreting correlation R. Just the linear relationship between explanatory variable and response variable is strength and direction. Sort of like context. Do not say exactly this. Those are fill in the blank options. Okay?
So what was R here?
R was like the value.
Yeah, I think they give it to you at the top, don't they?
Yeah.
Top
Or
right.
me or them?
Top right.
I'm asking you.
Oh,
I couldn't
okay.
remember.
.987.
Yeah.
Whatever you have.
I would say, because they're asking us to interpret it there, so can you write it?
Yeah. The
Or R equals
relationship
0.987.
between, what was our explanatory variable here?
Well, sorry, I was saying, write R equals
Oh,
0.987. I want them to try to use that
Oh, okay.
to interpret.
Is this gonna be on a
in their
mock
small groups.
exam?
Yes. The whole unit will be on a mock exam. I'm going to try to take a few minutes on Friday to talk about chi-square test, but it'll have to be on a mock exam, just see where we are. That means that we should only increase in our scores from the mock exam if we finish covering everything.
So do you
Or when we
count
finish.
the mock exam as our final exam?
Not where I count that as, I just take what your grade is.
So when do we take the final?
Be so for real right now.
So,
None
I,
of you
I don't
have
know
this
if I
out?
forgot this.
dog, you all got
Get
this
this
last.
out.
I looked
No,
around, I didn't
honestly, I
have
was
it.
thinking my
No, you have this.
I
This
know
is
we
the
did it on-
second
on
lesson.
When do we get it?
I remember.
Wait, when do we get it?
Alright guys,
I
interpret!
promise you, I was kidding my
Oh, I
mind.
gave it to
R
one of your
and
friends
R
to give to you.
squared. It is on
I gave it
there.
to-
Let's
Oh,
go.
really?
Write it down. Interpret it. Go, go, go.
I gave it to Braden to give to Jake.
Are you sure?
Yes.
I was cleaning out my mind.
Yes.
I don't have it.
Yeah. Woo. So
Are we incorporating the fourth one or the second
Both.
one?
the first, yeah, both boards.
Let's do both. It gives you a template.
Let me talk about the coefficient of determination first.
Oh, wait. Just kidding. The first one.
Just the correlation.
30 seconds. Run as fast as you can.
Is this individual or?
I mean, whatever
Which
you
one's
want to do.
explanatory, which one's response?
Hey.
Explanatory would be the one.
What explains and what
Independent.
I can't read like what's on
Dependent.
here.
Girl, I'm...
Independent.
Okay, I see. Woo.
I just couldn't read it, leave me alone.
Sorry.
Huh? What'd you say? Huh?
10 seconds.
Should we say very strong?
So that's a positive.
Define what the.
Alright, so the linear relationship between, what was our explanatory?
The
Number of rubber bands.
I'm just gonna put RB. And what was our response?
Distance traveled.
Distance traveled is, okay, Serena asked, is this strong? If it is extremely so strong, what's it gonna be at?
1.
Close to 1.
Above
Something
0.95.
This is what?
Pretty strong.
Really close to
Pretty
1.
strong. So we're gonna say strong. And what's the direction?
Up.
That feels weird.
Up.
This
Up
way,
to the
this
right.
feels weird.
Yeah, that's fair.
Because it just
northeast.
says strength and direction, but where do we, like linear?
Well, it already says the linear relationship.
Oh, it does start with linear. Never mind, guys. Sorry, that's on me. That's on me.
I will say this is not the way that I traditionally interpret it. This is what mathematic has. What I will usually say is the relationship between the number of rubber bands and distance traveled is a strong linear, strong positive linear relationship. Strong, positive, and linear.
You have to have the adjectives.
So you had to talk about the strength, you had to talk about positive or negative, the direction, and linear. So by saying linear relationship from the beginning, you've already taken care of that, that's fine. That's just not the way I usually write it.
So is there any?
Would it be
other
as a-
relationship than that?
instead of
Does
is?
it work on the AP test?
Yeah, both words.
Oh, is there any other kind of relationship?
So like, the reason why I say that is that's how I was taught
Linear?
by people who
Or-
were scoring AP exams before I
Linear or
even started
non-linear?
scoring
That's
AP
what we
exams.
got.
Quick note here, Serena asked, is that strong, guys? What's the range that we said for a strong linear relationship?
Above 0.8.
So 0.8 to 1. What's the next category?
I'm up
Moderate,
Moderately strong, which is
0.5 to
0.5 to 0.8.
And then 0.2 to
Weak
0.5
is
is weak.
0 to 0.5.
Yes, 0.2.
Not 0.2 to 0.5.
0 to
0 to 0.5. We would say weak or none, basically, if it gets close to 0, but we didn't say 0.2 to 0.5. 0 to 0.5 was a weak, linear, or essentially none.
Oh.
I promise. Yeah, so let me pull up this data.
Mind you, this close. You can twins.
Alright, so here's that candy grab data that we collected. Y'all remember all this?
Yes.
You remember all this, right, Jade?
Yeah.
So we grabbed our,
Here.
was it
Oh,
candy?
yeah, I was told about this,
Oh, he was?
Okay, so when we look at this candy grab data, how do I measure the variability in this data?
Standard deviation.
The standard deviation, right? And I don't like that mathematic did R squared here. I'll talk more about it later. but there's a standard deviation. And remember, when we calculate standard deviation, what's the first real thing that we do with standard deviation?
Find a mean,
We find the mean, and then after that we do the value minus the
oh, the
mean.
we don't have to do this one.
And then value minus mean, what do we do with that?
Add like here for every value and.
Like the
Not
sum.
yet.
Isn't that
Not
the
yet.
Oh, I swear.
Thank you. Remember, we have to square everything to make it what?
Very,
Positive. Yeah, we gotta square everything to make them positive, okay? No, I gotta teach.
Don't forget to follow our 4 Patriot
I
Police
got another
every day.
shot.
We want safety, achievement, unity,
So, we gotta square it,
showing
right?
respect.
So, each of these data points has a deviation that's then squared. Unless you're an AP. They already told me that. So, the difference squared. However,
Chick-fil-A Leader Academy, our final meeting this year will be Wednesday, April 23rd, after school in the library. We will have
So-
snacks, certificates, and senior graduation awards. And we will present our donation checks to High Socks for Hope, makes plans to attend.
so one thing in real world data, sometimes you clean the data to make it a little bit better. Does anyone see any data points that are unlike the others?
Serena.
That's right.
Serena's killing
You gotta call her out like that. Okay, hey, we're gonna talk about this later. Does anyone have an idea what we might call this point?
Potential outlier.
Potential outlier, right? So we're gonna talk more about what that really means later, but what I do want you to understand is this. If I look, does anyone remember what the mean was? 24, is that what it looks like? Okay. So right here, that's basically right on the mean. Right here, the distance to the mean, and then I would square it. Hold on to this idea of a square
The
later.
least squares thing?
We'll get there eventually, don't worry about
It's like
that.
Raymond's.
Right here, okay? This has a square associated with it. And so what we essentially did is we took all those squares and we added them up to get standard deviation, right? X minus x bar squared, right? We would take all those squares and add them up together. But I want you to think about this. If I now am using this, let's use a different data point. I'll show why in a second. So there's this square. That's not a square. That's close enough to a square. Alright, so there's a square. I want you to notice how big that square is from based on the mean, right? If I do it to the trend line, is that a bigger or a smaller square? That's a smaller square, right? So what does R squared measure? R squared is measuring how much we reduced these squares by using the trend line here, or the linear regression.
I don't understand.
Okay, so
You will.
we'll see it more later, but you see how we have this big square here? When I look at because that's the distance from the mean squared, right? This is the distance from the mean squared.
So it makes it closer to the mean.
So what we're doing is we've looked at this linear relationship. The idea is that the linear relationship is explaining that. So why is this value so high? Well, because someone had a larger hand, right? Why is this value so high? Because Mr. Kenny is competitive. But at the same time, right? Okay. But again, so why does this person have such a low grab? Because they have a smaller hand. So this line, this linear, I mean it's perfectly on the mean,
That
but
person's a big hand.
but again, so here's maybe even a better example right here. See how large this square would be? That's not a square. I get it. See how large that square is?
Sure.
But if I look at the square from my trend line, is that going to be a bigger or smaller square? So this trend line is going to have a smaller sum of squares. Okay? The linear relationship is going to reduce the sum of squares. The question is, how much does it reduce the sum of squares?
Is that what the all square is?
That is what R squared is revealing. So R squared,
Is that like
I like just like value square.
so like right here, that's not what I wanted.
from
I feel like this requires like
yeah,
prior
that just
polynomials.
reminds me of this.
So what is R squared doing? It is the percent of variation, or the percent of variation in the response that is explained by the linear relationship with the explanatory. So, when we look at this r squared, what was it?
0.9.
7.4.
Okay, so r was 0.987. Any guesses how I can go from here to here?
Minus. Where?
Squaring it, yeah. So, interpret r squared. So what percent of the variability in my response is explained by the explanatory? What percent? 97.4% of the variability, or variation, either one you want to say, variability in, what's the response? Because remember, that's what these original squares are from. So in the distance traveled by the Barbie, right? So the distance traveled is explained by the
Linear
Linear.
relationship with the number of rubber bands.
I will probably readjust this in the future with the number of, because I don't like them covering r squared here, but that's what we got so far. So the idea is, I would have bigger squares if I compare these values to the mean of them versus if I compare them to the regression line. So what we're doing is we're taking the sum of these squares and we're reducing it. So 97.4% of that variability is explained, or the variation in the response is explained by the explanatory. Do we have all that written down, Jaden? Everyone else have it written down who has their paper with them? Michael?
Mine's at home.
That was a bad decision.
Cleaning.
That was a bad decision.
I should clean out my binder.
Kidding, guys, right?
Alright, correlation. What are the three things?
Direction.
Direction,
The fear.
form, and then
Slant.
What does that?
Strength.
right?
Yes.
That isn't it. What do you
Dude, I
think
thought that was
that
like an M or an E or something.
Hey,
Alright,
quick
when we
word of caution. The correlation on its own cannot tell you the form. What else do you need to look at to know the form?
A graph.
You need to look at the scatter plot, okay? The correlation itself does not tell you the form. It has to already be linear for you to then talk about direction and strength.
Well, what if you had like a not like a scatter plot, but like a chart, and you're like, this is pretty obvious, like 1 and then 2 and then 2 and then 4.
Make a scatter plot.
Make one.
Yeah.
Do you have to make one on the exam?
No.
Oh, I was gonna say what?
Usually, I don't think I've ever seen them have you create a scatter plot. They give you scatter plots and you have to interpret
Yeah, I was
them.
about to say.
Or explain if it's linear or
We have to
not.
go for 80 bio for Qs.
I mean, most people have TI 84s, which are not as effective, but they still
You
have.
went in your way, it's not on here the way you do it.
That's fine. You can write it the way they have it.
Where is it?
That's fine.
Direction, form, strength.
Yeah, the relationship between explanatory response is
That's okay, I got this.
direction,
I got this.
strength,
Strength and
form.
form.
Coefficient of determination, just have y'all refer to what's already on there. I just want to focus on that next piece and at least start squared up. Any guesses? Yeah, good.
Correlation, causation.
Not a thing.
Correlation does not equal causation.
Observational study versus experience.
Yeah, you can only make an inference about causation in that case. All right, log on to a calculator quickly.
I
Do that.
gotta kill those. Do that check your understanding at home.
was logged into it and it logged me out, I'm so bad.
Sorry. I stopped class because I didn't think anyone was logged in. This is like a pretty
Look, girl, she
standard.
took initiative and you shut it down.
I
Yeah,
know.
that's exactly it.
Wow.
Teach
It's
me
actually your fault
alone.
tonight, that's why I shut her down.
Oh.
Why'd you do
has
that to
nothing
me,
do with
Samaya?
me. This has nothing to do, and you will see your
I don't think your
believers.
network.
Why'd you do that to me?
I don't think your network is working, Mr.
Yeah, it's not working.
Yes, it is.
Works.
Oh, well, excuse us, dang.
Make sure you're on
Jose, yeah.
I'm on
Mr. Kenny's and on Miss Williams.
7403.
I don't see Mr.
Yeah.
Kenny.
It's squared up, right? You just
Yeah,
gotta
Oh,
lock
I
squared up.
see it. My stuff was just wasn't working at the time.
Square up.
Get it?
Yeah, this hat's not working.
Pardon me, I
Let's
was
get
like,
another one.
So see how he yelled at you for no reason?
Alright, so this is how good are the predictions for Barbie, but we're doing it with a squared up task. I believe squared up is the next sheet, and then we said the Barbie thing was after that. Okay.
Square it up. Square it up.
Probably just gonna have to introduce.
Square up.
Alright. Yeah, we only have a couple minutes. I'm just gonna show them the tech component to get them ready. Alright guys, so go to 1.2 quickly. What you have here is the years 1900 up to 2004, and then the lifespan of men, the lifespan of women, and the lifespan of a person through those years, or in the United States. So what I want you to do,
What's the difference between a man, woman, and person?
Isn't the person the
the
component?
person is all the people, not just men or just women.
Abby.
So, if you could put year on your, well, I say that, what is explaining what? Is the life expectancy explaining the year, or is the year explaining life expectancy?
Year.
Okay, so year on your x-axis, life expectancy for a person on those years on the y-axis.
Portion.
Creates a what? Scatter plot. Is that linear?
Yeah.
Yeah, it's debatable.
It's debatable. We're going to talk more about that soon within this. What I need you to quickly do, technologically, go to menu,
What?
go to analyze. The directions are on the sheet, by the way,
You're like the wheel of fortune.
and add a movable
I'm
line.
pressing your network is connected, but it's not.
Whoa.
Okay, it's just connected.
There's a line.
No, I promise you, I promise.
Okay, so it should have a movable line.
I can move it.
Oh, really?
Oh my god, I love playing with things.
Oh,
We'll have to figure it out. Pay attention up here tonight. Alright, so it should have a movable line. Technologically, all I need you to see is this. If you move your cursor to the middle of the line, it creates the crosshairs basically, and it'll allow you to move the line up and down. Notice in the equation, what's it changing?
It's like wide.
The y-intercept, there you go. If you go to one of the ends, it gives you a circular thing, and that's going to let you change the
Oh my gosh.
slope, okay?
Whoa.
You are making your own movable line.
Ah.
Are we gonna see you?
Do we get a prize if we get
Whoa.
close?
We are
Well,
going
this
to
is
see who can get the
crazy.
closest.
Wait, I'm gonna look at the next
One
page.
now?
I just got like.
We got 90
I'm
seconds.
gonna look at the next page.
Oh, dude.
I don't think we're gonna.
Never mind.
This is my.
Go ahead and, well, we can actually do this. Here's what I now need you to do, is I need you to go to menu, analyze, and go to residuals, and show your residual squares. Those squares look familiar?
Yeah.
Do this.
Yeah, similar to the squares you did on the board.
I look at you made that.
What I need you to go ahead and do is take the time we got, no, I didn't need,
It's not like make it up.
take the time to try to make this sum of squares as small as possible. So move your line around so you can get a smaller sum of squares than that.
Okay. I can't barely grab my left here.
No,
It's just all right.
you can get scatter plot.
So click on it. And then.
Scatter plot. Menu, analyze, add a movable line. Menu, analyze, residuals. Show your residual squares. And you want to make that sum of squares as small as possible by moving that line around. Okay.
Grab it. You have to